B base, oh sorry, B, then what?
B base log.
Then base log, like this?
No, the log on the bottom. Yeah, and then.
Oh, the log B?
Yeah, that ever happened?
No, I don't think I've ever seen anything like that before. Never seen an irrelevant either. She didn't hear me, she's on her phone. So, equations. A lot of times when we're going to start solving these equations, we're going to utilize some of the same properties we've done in the past. What we try to do here a lot of times is, if we can, when you have values with exponents equal some value with another exponent, nothing else tacked on to one another, you want to try and see if you can get them to rewrite within a common base. Because if you get common bases on both sides, the exponents have to equal each other. All right? So I'm looking at this, I have a 4 and I have an 8. What would be my common base between a 4 and an 8? 2. So this is 2 squared times 3x is 2 to the 3 x plus 1. Since those bases are the same, the exponents have to be equal to one another. How much time you got here? Okay. Since your bases are the same, all you do is set your exponents equal to each other, and it's a quick 2-step equation. You get x equals 1. Now, I will suggest that you take a brief minute or two and you double check, make sure everything works. The math here isn't difficult, and checking answers is also pretty simple. So if I have x is equal to 1, well, what's 3 times 1? 3 times 2.
6.
So on the left side, I have 2 to the 6th. What's 1 plus 1?
2.
What's 3 times 2?
6.
So does 2 to the 6th equal 2 to the 6th?
Yes.
All right, you did right. Go to the next problem.
Yay! How did you get the 2 times 3x out of 5?
No.
I rewrote the 4 as a base 2.
Oh, I see.
I just wrote that, same thing with the 8, wrote it as 2 cubed. Right. Same idea here. I have 9 to the, I have 9 to the 2x equals 3 to the x minus 6. Get the common base.
3.
3. So you only have to rewrite one of them. Psst, put your phone away.
Thank you.
And again, since you have the same common base, your exponent values drop. All right. You get negative 2. Wait. Okay. So now, check it again. What's 2 times negative 2? Times 2. All right, so you have 3 to the negative 8 on one side. What's negative 2 minus 6? And you have 3 to the negative 8 on the other. Did you do it correctly?
Yes.
From the next problem. Didn't write this as clean as I wanted to. What happens when you can't get a common base?
You cried.
Log in.
You log it. For you. So what you do here is you log both sides. which base do I have to use?
The one with the X.
2, the one with the x, because I'm using this property here. Log base b of b to the x, it drops it through. By taking the same log base to both sides, I'm going to get x is the log base 2 of 7. Yes, sir?
Didn't we just multiply 2 by, do 2 to the power of 1/7?
No. In order to figure out, to undo that exponent, you have to have that common base. And the common base here, to make this become a value that you can work with, you use this property. So you use your calculator, you use the alpha window 5, I believe, and that gets your change of base, and you just type it in. Yes, sir?
When we're showing our work, do we have to go with that little step where we actually put log
No.
base to?
It's not always going to be this quick. There you go. That's just common law. Okay. Now, again, this works out to be a multi-step problem, but it's not very difficult to do. You still work your way backwards. Because you want to undo the property.
So you can just pull it.
Yeah. Yeah, so if it was like 3 to the x equals 7, you do log base 3. Yeah, you want to have that same base. Okay. So if I'm looking at this one, what's going to be my log base?
10.
Okay. But I still have to move everything else first. What do I have to move?
-4.
Good. Subtract the 4 first. Just like working with exponents and things like that, you have to get rid of everything else before you can square root and do all that other stuff. Same principle. Move everything else around. 10 to the 2x minus 3 equals 17. What's the log base? 10. This is your common log. So I get 2x minus 3 is the log of 17. Sir?
So we're going to get a lot of bad lessons.
Yeah. Okay. Put away your phone. Use a calculator. So log 17 again is some crummy number, and it's just a two-step equation. Add 3, divide by 2. Yeah.
Technically, there's like a log 10 for the 2.
Yeah. Your common log is 10, so if it's a base 10, you don't have to hit alpha window 5. If you want, go for it. It doesn't matter. You get the same answer. So eventually, when you set this up, you're going to get x will equal log base 10 of 17, add 3, divide the whole thing by 2. And there's your decimal answer. Whatever that is.
Is that a,
I just said it. Take your calculator out and press the button. Where's your calculator? Take it out and press the button.
is that a thing right here? 17.
Yeah.
Is that log then 17 or is that
Yeah.
log to the 17?
Log base 10 of 17 plus 3, divided by 2. Log 17, enter, plus 3, enter, divide by 2, enter. There's your answer, 2.12. Always go 2 decimal places, okay? Always go 2 decimals.
Not 3?
No, 2. Obviously, at this point, then you can go ahead and resubstitute back in and check it. You're going to be pretty close within rounding error. Yes, ma'am.
You actually have to find the decimal.
I was just lazy. Didn't press the button on the calculator.
Yeah.
Unless I ask you to leave it in exact form. Usually it'll say rounding error something. Sometimes you have logs on both sides of the equation. If you have the same log base on both sides of the equation, whatever they're taking the log base of, those have to be equal to each other. Same idea when we had same base raised to an exponent. Once you have the same bases, the exponents had to be equal to one another. Here I have the same log bases, which means the stuff in parentheses have to be equal to each other. One way to get around the log stuff is that you can undo your log by exponentiating. If I raise this as its own exponent, I get 3 to the log base 3 of something equals 3 to the log base 3 of something else. Those log bases drop out, and you get 5x minus 1 is x plus 7. And you get 2. Tricky?
You don't have to go through like the way that you raise the log to.
No, because you're using the property. But you can get away with this without even having to do that, because are these the same? Yeah. There's the same thing, there's nothing else tacked on there. You just use it.
Is that a way to solve logs
David? Sir,
Never mind, that's sort of what I was going to ask.
we'll get there. All right. All right.
Yes.
Log base 2 of x plus 2 equals log base 2 of x squared. Do you have the same log base on both sides?
Yes.
Okay. So you just set whatever's left over equal to each other. And then how do you solve something with an x squared? Factor. Set aside equal to 0 and factor. What times what's negative 2? You add together to get negative 1.
1 and 2. Yep.
Which gives you 2 possible solutions at 2 or negative 1. Now, you want to get in the habit of checking your answers, because eventually you might come across an extraneous solution. You might come across something that's a no solution. These are very easy to substitute in. You can do it in your head. What's 2 plus 2?
4.
What's 2 squared?
4.
It's going to work out.
4.
Okay? What's negative 2, or excuse me, negative 1 plus 2?
1.
What's negative 1 squared?
1.
Those are going to work.
Yeah.
Both values work. You have 2 solutions. Okay? That's the same thing. Sometimes you only have log on one side. Let's see if you can go the rest of the period without playing with your phone. Try it. Since I've asked you once to put it away, you've grabbed it 3 more times. Mouth off all you want. Keep it away, all right? It's not going to kill you. This is where you come into the properties where you have one with a log, the other without. To undo a logarithm, that's when you raise it to become an exponent. This logarithm has a base of 5, so what should be the base of the log base that I put? 5. This is what we call exponentiating. You're turning it into an exponent by putting a 5 here and here. These bases are the same, so this falls and you get 3x plus 1 equals 25. Yeah,
Why did you put the 5 like below?
because I'm using this property. It's the base. I'm over-exaggerating that it becomes a base of a log base. I'm using the same base. And I'm keeping things balanced by putting it on both sides of the equation. Yeah.
Those the only two,
Really it is. The only two we really worry about. For undoing a lot of the equations, this is a lot of what we do. Don't get me wrong, you'll see some condensing and some expanding, but a lot of times it's just going to be these two problems we worry about. Okay. You get 8. Check it. 3 times 8 plus 1 is 25. Log base 5 of 25 is 2. Because 25 is 5 squared. And you can use properties real quick to check it as you're going back and forth. Okay. Yes, sir?
That's called exponential.
Yeah. I don't think that's technically the real word for it. That's I kind of coined it. It works because you're raising it to becoming an exponent. So kind of it works. All right. It can get a little goofy if you're not careful, though. Excuse me. Yes, ma'am. It could happen. It could happen. I don't think, or it could be a no solution where it works itself through. You get like 0 equals 18 or something like that. You know, it does happen. Yeah, yeah, because it only takes a second. Like I said, a lot of this stuff is just so fast. Okay, it's so fast to check. All right. Now on this one, you have properties thrown into it. What happens when the 2's out in front of the log? Square. So let me show you what happens. There's 2 ways you can do this. There's 2 ways to go about this. When you have a number in front of a logarithm, that means it's an exponent of whatever the log you're taking the log of. Everybody remember that?
Yeah.
So, what you can do here is, well, obviously we move the 15 first. Everybody okay with that?
Yeah.
I move the 15 first. I'm going to get log base 2 of x squared is 16. All right. How would I undo a log base 2? 2 to the log base 2 to both sides. So then I get x squared is 2 to the 16th power. I don't know what that is. Big number. But before I even bother with that, how would you undo squaring? Square root. So if I'm taking a square root, what's the power I'm raising it to?
1/2.
So if I take this to the 1/2, I take that to the 1/2. So now x equals 2 to the 8th. One way to do it. The other way, work backwards. Subtract 15. How do you undo times? Divide by 2.
So you can't have taken the square root of
What's that?
it? You have taken the square root of like 16.
No, because you're using the exponent rule. You're taking the square root of 2 to the 16th power. 2 to the 16th power has a square root, it's 2 to the 8th. Because use the property of exponents with your nth root by creating the fraction. And that drops it through because now, what happens on that side? You get 2 to the 8th. Either way works. If you condense something with an exponent and then go through the process by taking the square root or raise it to the 1/2 power, you're going to get the same result as if you just divide by 2. So you don't necessarily need to condense to an exponent to make some of these work. Okay? A lot of just the pure order of operations, thinking about in terms of it's 2 times the logarithm and working your way backwards, is still going to work just the same. Yes, ma'am? If it's, to be honest with you, when you get down to something like this where it's like 2 to the 8th, that's going to be a bigger number. I mean, all right, I know it's 2 to the 8th, it's not that bad, but if it's something like 3 to the 8th, 3 to the 8th is huge. I don't care what that is. It's like 3 to the 8th. But at 2 to the 8th, yes, you can press that only.
Well, considering how many numbers there are.
I bet you the square root of that is, it's 3 to the 4th. 81. Okay. When you have 2 logs on one side and none on the other, you have to condense before you do anything. Because you're not going to have, I know you guys were wondering about what happens with the multiple log. You can't condense something if they have different log bases, okay? That won't work. Everything, I'm pretty sure everything that we worry about is going to have the same basis, or even with natural log. And I'll do an example here in a second with natural log and with E. It's pretty easy as you work through it.
That was so fun.
Oh, it wasn't. So if I want to condense this on the left, what do you do? Math. Very good. So this is log of 5x times x minus 1 is 2.
Oh, I see.
You 10 it, right? So I'm going to 10 it to both sides because common log base is 10. You don't see it, it's 10. So these undo each other. This becomes 5x squared minus 5x equals 100. Set aside equal to 0. And what's your first rule of factoring? What is it?
5.
What times what's negative 20? You add together to get negative 1. Thanks for keeping up with us. So you have 2 possible solutions then. 5 and negative 4. Again, go back and see if it's going to make any sense. If I use 5 or negative 4. Well, right off the bat, I'm looking at that negative. Can I take a log of a negative number?
No.
So I can't take the log of negative 20. So I know right away that this one throws out. That could be extraneous. But remember, earlier I had an answer where it was negative 1, I think. But that one worked. Because the way we were substituting back in, it wasn't giving us a negative value to take a logarithm. It was negative 1 squared. I think it was negative 1 plus 2. We didn't have to worry about it. So you always double check your answers to see if you get an extraneous solution. Yeah.
Okay, I'm confused. On the first log, you said you exponentiated it to 10. What happened to it's like log plus log. What happened to the second log? Is it
Since it's thrown in there with log 5x plus log of x minus 1, that plus sign from yesterday means they're being multiplied together. So you have to condense that. So like whenever you have 2 logs on one side, condense them. Whether it's a subtraction or an addition or something like those things. Anyway, yeah. Always go for a GCF and it drops out a lot quicker. Yeah. Because think back to polynomials. Did our constant even matter? Let's do an E1. Yeah.
What's 0 divided by 0?
Undefined.
It's
You can't divide by 0. Let's work with E. Okay. Where do you get right away to make your life easier?
multiply everything by
Multiply everything by 3.
yeah, smart.
Now what? Check 1. Divide by 2. How do you undo E? Very good. Natural log undoes E. Okay? So if I take the natural log of both sides, I'm going to get 4x equals the natural log of 11 over 2. That's a crummy decimal. To that crummy decimal, what do? Divide by 4. And there's your answer. Working with natural log or working with E, to undo a natural log, you E it. To undo an E, you natural log it. You do all the other steps like you would normally until you get to that spot, and then you just undo it with that. Yes, sir?
Can you scroll to the top? It's like,
Who invented all this
Why?
What's the point of all this log and natural log and
It's the same idea of when you're trying to find that 2 to what power is 6. Sometimes you need to know. Yeah.
Why did you guys
Got rid of the fraction. Just make it easy. So, did I have to? No. You got a calculator? It's just quicker. You're gonna get the same answer.
Got it. It's like a little off topic, but math is fairly constantly like used to
Give us that
Kobe Schmierbach.
Kobe.
Oh, I have a lot.
Oh, I'm sorry, Sam.
wait, Mr. Murphy.
Yes, sir.
Can you go back and count to 5? I can write it in class.
What's that?
Can you go back and count to 5? I can write it in class. I just said it was just the last one.
And whatever the decimal is. Remember, what you have to do here when you're putting this in the calculator, shh. I'm leaving it in the exact form. If I'm putting this in the calculator, once you press natural log, see how it opens up in parentheses? Do 11 over 2, close the parentheses, hit enter, and then just hit divide by 4 and hit enter, and there's your answer. 0.43.
Do we have to do that, or can we keep it?
It'll say, it usually says around the nearest 100th or something like that. Don't get me wrong, because if I do calculator, non-calculator stuff, I could have you solve these equations all day. Jeez, that's awesome. I can have you guys solve these equations and leave them in exact form. Because you don't need a calculator if you're going exact form.
Give us that.
Same thing when you're looking with the natural log. Properties mean the same. Properties work exactly the same for natural log. It's log of the natural base, I believe it stands for. I have the plague. Since you have 2 natural logs on the one side, you got to condense it right away.
like milk.
Just get the natural log. Boo. Boo. And then how do you undo natural log? You E it. So you have to E both sides, because remember, natural log is log base E. So you're exponentiating it with an E. So you're going to get x squared plus 3x equals E. I'm glad you asked. If I set aside equal to 0, isn't E some number?
Yeah.
I don't know what times what is negative E that adds to positive 3, but I could probably use the quadratic formula, couldn't I?
No. Let's just leave it as.
Not? We could not.
Fast you guys turn, seriously. What's wrong? What I want you guys to do.
Why can't we just like, what is this? It equals F.
What's up? I couldn't hear you. What's that?
As soon as we write this down.
Yeah. I just want to see what page. I forgot what page it was.
Gosh, Murph.
Oh, sue me.
I will.
505. Okay. If you want to set them up, round them out to 2 decimal places, that's fine. I think that's what all the instructions were for most of those. Make sure you're checking your solutions, okay? Some of them are going to work, some of them might not work. You might get 2 solutions, you might get 1 solution, you might get no solutions. Remember, when you're checking these things, they are really fast to be able to check. A lot of it you can probably do mentally. Okay? Which one did you want to look at now? Sure. Yeah, you would use quadratic formula to solve out for. Well, yeah, that's how you solve for x. You're pressing buttons on a calculator. I know, I'm such a jerk making you use a calculator.
Wow. If he's not making us use the slide ruler.
I'm not going to figure that out. I'm going to use a calculator.
How do you
Better than me. And I don't appreciate that. Look at this, look at that, look at that.
Yeah. And with e to what power? Yeah. Because as soon as you hit the e button, it's going to bring you to an exponent. The exponent here of e is 1. Because it was e to the third. Okay? Oh, it's just a crummy number. It's going to be 9 plus 4e. Whatever that is.
Well, it's negative.
Negative 4, negative e. So there.
Plus.
Correct.